Hello, and welcome to iOS 103, Make Your Images Look Great on All Devices. So one of the main objectives of building a mobile application is making it visually appealing to your users. And one way that we can do that is by adding images into our application. Now you may be thinking, okay, well, adding images can't be that hard. But it turns out that in iOS development, there are a number of different devices and form factors that all have different size resolution devices. And because of that, there are some challenges when adding images into our applications. So today we're going to get started with looking at how we can just take an image file and include it into our application. And then we'll start looking at how we can take that image and display it to our users. Then we'll start talking about more of a UI design guideline on how we should design our UI when images are there. And we'll look at how we can use points to constantly size our UI image views on the screen so that they appear to be about physically the same size across all devices. Then we'll take a look at how we can provide multiple versions of the same image at different resolutions, and that will allow iOS to choose the best version for the device being used. And then finally, as sort of an optimization, we'll take a look at asset catalogs and image sets, which are ways of organizing those multiple resolution image files. So let's begin with taking a look at how we can add an image into our application. And there's a couple things we want to talk about. First, we'll look at how we can actually take the physical asset and add it into our application. And then we'll also look at how we can set the asset's build action. So let's start with, well, what exactly is an asset? So an asset is a non-code file that we want to be included in our application. And there are many types of assets that we've worked with and seen, things like images, audio files, and videos, some type of data file, maybe a JSON file, an XML file. These are all common types of assets. Now, when we want to include these in our application, we have to include them in what's called the application bundle. So the application bundle is like a folder structure that will basically contain everything that the application needs in order to run successfully. And it contains things like the info plist file, which has information about your application, like the application's name. It contains the actual executable file, and it will also contain all of our resource files. These are our assets. Now, when you add an asset or a file into your application, it will get assigned a build action. So a build action is basically a piece of metadata that controls how the build process and toolchain will actually process that file. And there are many types of build actions. Here are some of the common ones. We have none, compile, embedded resource, and bundle resource. Now for us today, we're basically interested in bundle resource. Now this is an iOS specific build action, and basically what a bundle resource is that it indicates that that asset or that file should be included in the application bundle. So that's what that ensures. Now, when you add a file to your application project, Visual Studio will actually automatically assign a build action for it. However, this value can be overwritten. So in the properties window, there's actually a drop down for the build action that allows you to change it and set your own choice here. Now, luckily for us though, when we're building Xamarin iOS applications, there's actually a folder called the resources folder. And the resources folder is basically a standard location that we should place our application assets. And when a file or asset is added into that resources folder, it will automatically be assigned a build action of bundle resource. Now that should work, but whenever you add a file to the resources folder, you should take a second just to verify that the build action is indeed bundle resource. Alright, so let's go ahead and jump into an exercise where we'll look at how we can actually take an image file and add it into our application bundle. So here we are in the starter solution of exercise 1. And our goal of this exercise is to add an image resource into our resources folder. So I want to first just open up the storyboard just to show you what the UI looks like. And this is a savings planner application. So you can see it has some basic fields for entering the starting balance, the interest rate, the monthly deposit, and the number of years to calculate your final projected balance. And there also is an about page which we'll use later on to add an image, so we'll have multiple images in our application. But this is the basic setup. So what we want to do is we want to add first the image into our resources folder. So we'll right click on the resources folder and we'll go to add existing item. And if you go into your lab materials in the exercise 1 folder, there's an assets folder and there's a little savings pig. So we'll go ahead and we'll add on that. Now when we add that, you can see it's now inside of our resources folder. And if I click on it and look in the properties window, you can see the build action is set to bundle resource. That's exactly what we want. So right now we're in a good position. We can go ahead and close this and we're ready for the next exercise. So far we looked at how we can add an image into our application and also how we can set that image's build action. Now remember, we want the build action to be bundle resource, which means that the file will be included into the application bundle. Now we're going to look at how we can display that in our user interface. And to do that, we're going to use a UIImage view. But before we can use a UIImage view, we need to create a UIImage. And then the UIImage view will visualize that UIImage on the screen. So what exactly is a UIImage? A UIImage is an object that represents an image in memory. So it's just an object that kind of stores and manages image data. And there are actually multiple ways of creating a UIImage. On the UIImage class, there's a few static methods, 2 specifically that are really common, FromBundle and FromFile. And you can see they both have the same signature, they take in a string. However, they differ in their caching strategies. So what do I mean by that? So starting with FromBundle, FromBundle will take in a string and it will create and cache a UIImage. So this is efficient when you want to display that image in multiple places. It will help with the loading time and it will cost a little bit of memory. But if you're loading it multiple times, it will be worth it. One thing to be cautious here is the string parameter. This is the file name of the image, but this is relative to the resources folder. Now the same idea applies with FromFile, except the only difference is that FromFile will not cache the image. So you should potentially use this if the image only appears in your UI one time. And once again, the string file name here is relative to the resources folder. Now, because everything is relative to the resources folder, you can imagine a situation where it may get a little cluttered and unorganized. So luckily for us, we can create subfolders inside the resources folder. So for example, here we created the images subfolder and you can see savings PNG is now inside of it. You have to be careful though, because when you load that file now, you have to prefix it with the subfolder. So now it would be images/savings.png. So remember, a UIImage is just really the image in memory. It's not actually displaying it visually in any way. If we want to display it visually, we need to use a UIImage view, which is a class that derives from UIView, and its sole purpose is to visualize a UIImage. So you can see here, we take the UIImage, which is an in-memory representation, and then we can plug that into a UIImage view to display it to our users. Now, we can connect the UIImage and the UIImage view in a couple of ways. First, we could do it through the constructor. So the UIImage view class has a constructor that takes in a UIImage. Or there's also an image property exposed on the image view that we can set. Most of the time you'll use the image property because that allows you to dynamically change it over time if you have to, and this could be useful for things like table views. Now, when it comes to creating a UI image view, there's actually two different ways. We could do it in C# code, or we can use the storyboard designer. So doing it in code is fairly straightforward. First, we create the UI image view. So we instantiate the view. Then we assign the image property. So we could use either FromBundle or FromFile to get that UI image object. Now, alternatively, you could also do this in the constructor of the UI image view. It's up to you. And then finally, we would want to just display the UI image view on the screen. So we would do that by setting the frame property and positioning it on the screen. Now, to do it in the designer, it's also relatively simple. You take a UI image view from your toolbox, you drag it onto an existing view controller, and in the properties pane, you can actually just select the image. The properties pane will automatically scan all the files in the resources folder, and it will pre-populate the dropdown in there automatically. With this technique, you don't have to worry about creating the UI image object yourself. That will happen for you. So let's go ahead and jump into another exercise and display our pig image. Here we are back in the Savings Planner application, and we're now going to try to display an image on the screen. So first, let's go to the storyboard, and we're going to do this all in the storyboard. You could do it in code if you wanted to, but the storyboard is just a little bit easier. So we have our Savings Planner view controller, and we're going to go ahead and go to the toolbox, and we're going to locate an image view. Once you have the image view, drag it onto the view controller and place it above the starting balance label. So right there. Now we're going to leave it its default size. We're not going to modify anything just quite yet because we'll learn more about that in the next objective. But what we want to do is we want to set the image. So if you go to the properties window, on the right hand side you can see there's an image property with a little drop down, and notice how it's detecting the savings image from the resources folder. So let's go ahead and select that, and right away in the storyboard designer you can see it has updated the UI, and you can see that it's also a little bit blurry, and we'll start talking about in the next section how we can fix this and some kind of guidelines that we can follow. But I'll go ahead and I'll run this application and let's see what it looks like on an iPhone 8. Alright, and here we have it. So depending on what simulator you're using, the image could be in a little bit of a different position, but we are using the iPhone 8 here. We can see the image. It's a little bit blurry, but we'll fix that. So let's go ahead and head back to the slides. So now we know how to take a UI image object and display it on our screen by using a UI image view. I now want to switch gears a little bit and talk about a concept called points, which are here to help us build consistent looking UIs across our devices. And the reason why this is important is because there are a lot of different devices. So for example, here you can see we have a bunch of different iOS devices, and in our application we want this pig image to be about 1 inch by 1 inch on every iOS device that runs it. So we need a way to be able to display that image at the same physical size because that's the resolution of the images we have. But if you think about it, every device has a different resolution screen, so that is a little bit challenging. So let's take a look at how we can solve this problem using points. Before that though, we need to take a step back and let's talk about what exactly is a pixel. So a pixel actually stands for picture element, and it actually represents sort of the smallest unit of an image or a screen. So for example, you can think of a screen as a grid of pixels, and each pixel is rendered as the same color. So for example, here on the screen you can see we have one pixel that's red, and obviously these pixels are a little bit bigger than they actually would be, but this is the concept of a screen. Now this leads to a more important concept called pixel density. Now the pixel density is the number of physical pixels per inch on a device. So on the left hand side you can see we have the original iPhone and 3G to 3GS. That's about 163 pixels per inch. As we progress and the devices get more and more new, like the 4 to the 8, you can see those are about 326 pixels per inch. And then the 6 plus to the X, or the pluses and the X, they're about 460 pixels per inch. Now, this is a good thing and a bad thing. It's good because obviously having more pixels means that we could display more data, which means we'll have sharper images, but at the same time, it's bad because the more devices that we have with different pixel densities means that designers have to design more assets to cover all of those different devices. Now, obviously, building assets and images for all of these devices would be really difficult and challenging. So luckily for us, you can see that there's actually sort of these natural groupings going on where the original phones like 2G, 3GS, these are about 163. The second group's about 326, and the third group's about 360. So there's actually a concept called the pixel density ratio. So the pixel density ratio is basically the ratio of the screen's pixel density to the original iPhone. So this is the original iPhone's 163, so its ratio is 1x. Then all of the 326 PPIs, they are 2x, or double the amount of pixels. And then we have the 3x, which is about approximately 3 times the amount. It's not perfect, but about 3 times. So this means that when we build our assets, we don't have to do it for every device. We could just do it for these 3 pixel density ratios. And we'll see more about this in a little bit. Now, because all of our devices have different pixel density ratios, it's hard to create a consistent looking UI because, for example, if I placed a control on the screen, this blue control, and I sized it at 150 by 100 pixels, on the 2G, 3G, and 3GS, it would look that size that you see on the screen, but as the pixels per inch increases, the actual size of the control will decrease because there are more pixels and the pixels are smaller and smaller, thus making the overall control smaller and smaller. We want some way where we can actually create a consistent looking UI because if we had a situation like this, imagine that blue control was a UIImage view and we're trying to display an image in it. You could imagine that because the actual image view is a different size on every device, it would be hard to make an image look great in every single version of it. So that's why Apple created the concept called a point. A point is really an abstract unit of measure that will take the amount of points you have and at runtime convert that into pixels for each pixel density ratio. And it does that by multiplying the points by the pixel density ratio. So for example, on our 1x devices, 1 point is really 1 physical pixel, but on our 2x and 3x devices, they're multiplied by 2 or 3 for each respective pixel density ratio. And what this allows us to do is something like this, where I can say I want this control to be 150 by 100 points. And now on every device, as you can see, the object is about the same physical size across the board. And this is what really allows us to create a consistent looking user interface. So let's jump into the next exercise and let's take a look at how we can size our image using points, and we'll also use some constraints. So here we are back in our exercise, and as you can see, we're in our storyboard. And our goal is to take this image and size it using points and constraints so that it's consistent across all of our devices and that it makes it easier to display an image inside of it. So to do this, it's relatively simple. First, we'll select the image view and we'll go to the Layout tab in our Properties pane, and let's set the width and the height of this explicitly to 140 in both dimensions. Now when I do that, I'm going to take the image view and move it back into the center of the screen a little bit. And now we're good. By just setting the width and the height here, that actually is using points. The only problem is we want now to say we want this to be in the same position on every device. So we're going to use constraints to just finish this up. So on the top right hand side of our screen, we'll hit the little constraint button, and then we can start adding constraints. So we'll first add an upper constraint. We'll say we want this to be vertically centered, so we'll take the center constraint and drop it in the center line. And then we'll also just give it a constant width and a constant height again. So now it should stay in place. So if I ran this again, we should now see that it will look consistent on all of our devices. And there we have it. We see the application is running, and we have our pig being displayed. In this last section, we looked at how we can use points to build a consistent looking UI. But now we're going to talk more about images again and how we can provide crisp images across all of those different devices. So we'll look at how we can provide a multiple resolution image and also how we can display a multi-resolution image in a UIImage view. So the motivation here is pretty straightforward. Once again, we have a bunch of different devices that are different sizes and resolutions and form factors, and we want to display a crisp image across all of those. And it's really not practical to create a separate image for every single device, so we try to maximize that by providing images just for each pixel density ratio. Before we can get into that, let's take a step back a little bit and explain, well, what exactly is a raster image? So this term, you may not have heard it before, but this is really in contrast to a vector image. So a raster image is really just an image format that will store every single pixel or the color of every single pixel. And there's tons of different formats, right? Bitmaps, JPEGs, PNGs, and so on. And basically what happens is each format will store it differently, but essentially the RGB values for each pixel is recorded. That's how these work. Now, when displaying a raster image on the screen, there's a number of algorithms that are used to do that. But in the simplest situation, you would see a one-to-one mapping, meaning on the left-hand side, that's our source image, and on the right-hand side, we're trying to display it on the screen. If the left-hand side, which is the source, has the same amount of pixels as the right-hand side, and they're the same size as well, we can literally map pixel to pixel. So the image will look exactly how it looked in the source. So this is the best case scenario that we can have. However, where we run into problems is where the source and the destination do not match in the amount of pixels that they have. And this could either be they have less amount of pixels or more amount of pixels. And in either situation, we have to scale the raster image to satisfy the new target area. And we don't really want to do this because scaling, as we'll see, always has bad side effects. So let's first talk about upscaling. So upscaling is the process of converting an image that has low amount of pixels to the destination that has more pixels. So we're increasing in the amount of pixels that we have. And when we scale, there's actually a lot of bad things that can happen. Obviously, if you think about it intuitively, if the source image does not have as many pixels as the target, it can't possibly look any better in the target because we're losing information, or we don't have as much information to satisfy the target. So there are some ways to get around this a little bit. There are algorithms that will try its best to make use of those extra pixels. So one standard algorithm is pixel doubling, where it will say, let's just double all of the pixels from our source in our target, and that the whole point of that is to try to maximize the use of the extra pixels. But when you do that, it tends to create more of a jagged image because you're really just doubling the pixels and you lose the crispness around the edges. So some of the more advanced algorithms will actually use interpolation to try to fix and smooth that out by making its best guess. So what these algorithms will do is they'll look at the surrounding pixels that it knows for a fact, and it will try to fill in the empty pixels by taking the colors and kind of combining them together and just smoothing them out. So you can see that's illustrated by this little light pink color around the edges. And this works as well. It will make the image a little bit smoother, but no matter what, it will never be as crisp as a one-to-one perfect mapping. On the other side, we have downscaling. And downscaling is where we have a high resolution and we're going to an area that has less pixels. Now you may be wondering and thinking, okay, well that can't possibly go wrong, right? If I have more pixels going to less, I shouldn't run into a problem. But there actually is a problem. And the problem is, if you think about it, we have to lose data. We have to get rid of some pixels. And if we're downscaling, we're leaving that up to the algorithm to decide what pixels should be removed. And in reality, what you really want to do is you would want to manually pick the pixels yourself, because the algorithm could pick the wrong things. Maybe you want to say, okay, because we have a smaller real estate here, let's not display its tail. And you can make those decisions to still create the best looking image instead of leaving it up to a computer, which could remove something that actually is important. So there are some steps and general recommended advice that you can follow to help create crisp images on all iOS devices. So first, step one is you want to determine the size in points. So you go into your UI, your storyboard, you design the control using points. Then step two is you want to calculate the number of pixels. So I know on 1x devices, it will be the same amount as the points. On 2x devices, it will be double the points. And on 3x, it will be triple the points. So make those calculations and then have your designer or yourself create assets at those exact pixel counts. So kind of going through the steps. Step one, right? We create the control, the UI image view, and we size it using points. So in this case, our UI image view is 150 by 100 points. Then we want to figure out how many pixels that is for each pixel density ratio. So for 1x, that's 150 by 100. For 2x, that's 300 by 200. And for 3x devices, that will be 450 by 300. We take those pixels and we actually generate assets at those exact resolutions. So in this case, we'll have 3 assets. So when we have these assets, we now have to provide it to our system in a way that it knows to use each one depending on the device that was chosen. So there are multiple strategies that we can use for providing multi-resolution images. The first is we can use a file naming convention, and we'll cover that in this section. And second, we could use a more new technology called asset catalogs, and inside of asset catalogs, there are things called image sets, which we'll cover in the next objective. So first, starting with file naming convention. How it works is this. We take all 3 versions of our asset and we place them in the resources folder. And the only thing that we have to do different is we have to tell the system that some of these are 2x and some of these are 3x. The way we do that is we have this standard naming convention. We use an @ sign followed by the pixel density ratio. Now, as you can see, we're not doing it for the 1x. The 1x is optional. You can put at 1x if you want, but you don't have to. So by using now these names, the system will be able to pick exactly which one should be used on each device. So for example, here we have our application now running. So up first, we have the iPhone 3GS, which is a 1x device. It will look at all of the images and say, oh, that is going to be the 150 by 100 pixel image. The iPhone 4 will be the 300 by 200 image, and the iPhone 7 Plus will be the 450 by 300 image. And it does that by looking at the names on the files for that asset. Now, when we actually want to load that image or load a multi-resolution image, there's 2 ways we could do it. First, we could do it in code. And notice how we're just using the standard UI image from Bundle like we used before. The only thing different is notice how in the name we don't supply the pixel density ratio. So that's kind of ignored. That work will happen automatically behind the scenes, and it will choose the correct image for you. Now, doing it inside the storyboard is even a little bit easier because, once again, the image dropdown will be automatically populated with all the images. And once again, it will not display the pixel density ratio. That is automatically implied, and it will be chosen for you at runtime. So let's go ahead back into our exercise, and let's now provide crisp images by providing 2 more versions of our savings pig. So here we are back in Visual Studio, and we're in the Storyboard Designer, and we want to add 2 more versions of the savings pig. And we're going to provide these at the correct resolution. So the first savings pig is actually as 140 by 140. Let's go ahead and add the other ones now. So we'll go to Add Existing Item, and we'll go to exercise number 4, Assets. So you can see there are 2 more pigs in here. If we look at the first pig, you can see that this is at 280 by 280 because the first pig's at 140 by 140. That's 2x. And our third pig is at 420 by 420, which is 3 times. So we'll go ahead, we'll include these into our project. Notice how the names are correct already at 2x and at 3x. And we're done. If we run the application again, it will now automatically use the correct version. So in this case, it's going to be using the 2x version because we're displaying it on an iPhone 8. So as you can see, the picture actually looks more crisp from the previous example. And you can go back in the video and take a look, but it's now more crisp because it's using the correct version image. All right, so now we know how to provide a multi-resolution image and also how iOS will choose and display it inside of a UI image view. The last thing that we're going to talk about for today is how we can organize our images using an asset catalog instead of that naming convention. So we'll first look at how we can create an asset catalog and how we can create an image set inside of it. Then we'll look at how we can load images into the image set and then display it in a UI image view. But why do we care? Why do we care? If we can use a file naming convention, why do we care about using image sets and asset catalogs? And the simple truth is, relying on a string name to manage what image should be used on each device is kind of error prone. For example, looking at this slide right now, you probably didn't even notice that there's a problem. This last version of the pig is missing an S, and this would cause the 3x version to not use the correct asset. And this could be hard to catch because you may not be always testing on 3x devices. So it's just error prone to be using strings as this differentiation factor. So an image set is really designed to solve that problem. An image set is kind of a GUI experience that will group together all the versions of an image for the different devices and scale factors. So for example, here you can see the 1x, 2x, and 3x image are all grouped together in this pig image set. Now there are different types of image sets. The first image set is a universal image set, and this is where the image set is used for every form factor. Basically iPhones, iPads, Apple Watch. It will use the same exact image set. But in contrast to that, there's also a device-specific image set. So you can say, I want this image set to be just for iPhones or just for iPads, and so on. And this allows you to essentially provide a different image depending on your device. Now, the general advice here is you should most of the time use a universal image set. As you can see, yes, here I'm displaying a different image on the iPad, and that is acceptable. But generally, changing the experience that much per device platform is not generally good advice because it creates an inconsistent use of your application. But if you want to potentially add more detail or to change up the image a little bit on an iPad versus an iPhone, it's not the end of the world, and you can definitely do that. Now, in order to use an image set, we need to know what an asset catalog is. And an asset catalog is really just a collection of image sets and other resource types. So there are other things like data sets and color sets. But for our purposes, an asset catalog groups together image sets. So how do we create an asset catalog? Well, it's very simple. Inside of Visual Studio, there's actually a predefined asset catalog folder. If you right-click on that, you can then select Add Asset Catalog, and it will ask you to type in a name of the asset catalog. You can call it whatever you want or leave it its default name. But once you create an asset catalog, it will pop up a menu, and then you can create a set. So there's a little button that has a plus sign that you can click, and then it will bring up this menu that has image sets, color sets, data sets, and all types of other things. We want to create an image set. So once you click Add Image Set, you'll get an image set with a universal image set as the default. Now you want to start adding images to these. You can see that there's little cutouts for 1x, 2x, and 3x. If I select the 1x, I can hit the little dot, dot, dot to browse for an image, and I can drop all of my images in. The thing that you should note here is that you don't have to worry about any naming convention. You can simply just drop the correct image into each. Now, when you do that, an image set also has the ability for some options, and there are some important ones that I want to point out. So first, in the Properties window, you'll see the universal image set option versus the device-specific image set option. So if you want iPad and iPhone versus universal, you can go and set that all in here. But what's probably the most important is the name. You want to set the name of your image set because this is how you'll access it in the storyboard or in code. So give it an appropriate name. So doing it from code is super simple. All we do is, once again, we're using the FromBundle method, and we pass in some type of string. But in this case, since we're passing in an image set, we just pass in the name of the image set, which is savings in this case. We don't have to worry about adding any file extension. It's just the name. And once again, the same idea applies with the storyboard. In the storyboard, the designer will automatically pre-populate the image dropdown with all image sets that are detected. And once again, no file extension is used. Now, I want to just point out one thing. The storyboard is a little bit buggy with this, and sometimes I've noticed that it doesn't actually detect the image set. So in that case, I would recommend just using the code approach, which is exactly what we're going to do right now in our next exercise. Here we are back in our exercise, and our goal now is to finish off this About page, and we're going to do it by adding an image using an image set. So step one is we need to add an asset catalog. So let's right click on Asset Catalogs. We'll go to Add Asset Catalog. And in this pop-up, we want to select Asset Catalog, and I'll leave the default name of media, and I'll click Add. Now when I do that, as you can see, it brings us into the asset catalog, and I can hit the little plus icon to add an image set. If I go inside the image set, I can now add images. So to do that, we'll hit the little browse button, and in this case, if we go to exercise 5, there's an assets folder. So we'll add the 1x, the 2x, and the 3x. Now I just want to show you really quickly that the 1x in this case is at 200 by 200, and it's 400 by 400, and 600 by 600. Let me just show you this. Okay, so what we want to do now is we want to be able to display this in our UI. But before we can do that, I want to give it a better name. So what we're going to do is we're going to go ahead and we're going to select on images. And remember, there's a properties window. So if you go into the properties window, there's a name field, and we're going to call this detailed savings. Hit enter, and let's save and close this. All right, so now let's go ahead and create the image view for our About page. So let's go ahead, let's find an image view, drag it on. And we want to size this at 200 by 200. And let's place it below our label. And once again, we're going to add constraints just to keep it in place. So we'll add a constraint that goes below the label, that centers it, and then constant width and constant height. Now we want to be able to set this in our code, so we need to give it a name. So let's go ahead and select it, go to the widget, and let's give it a name of pig image view. And when we give it that name, if we go into our code behind, which is the about view controller, I can now access it by that name. So what we're going to do is we're going to override the viewDidLoad method, and our job is to load that with the detailed savings image set. So we'll say pig image view dot image equals UIImage from bundle, and it's called detailed savings. That was the name that we gave the image set. And just like that, if we go ahead and run the application, we should see the image being loaded from the image set. So if we go now to the about page, you can see our image is being loaded. So in this last section, we looked at how we can create an image set inside of an asset catalog to help us organize our multi-resolution images. And this was better than using the file naming convention, because with that, you could easily make a mistake because everything's based off of some strings. We also looked at how we can display an image set inside of a UIImage view. So that brings us to the end of the course. I want to say thank you for taking the time to listen and watch this, and enjoy the rest of your day.